me just kind of jump into it. So the basic function is it's a point repair system for pipes to eliminate leaks from the inside. So sometimes they'll do dig and replace, and they'll do liners or grout. This is our solution. It's a targeted repair generally used on joints, but other compromised points as well. So it's comprised of an EPDM rubber sleeve and stainless steel retaining bands, and those retaining bands hold the rubber in place over the repair area. So both the rubber and the steel are manufactured in-house by us, so they specifically fit the pipe when they go out. So that's what that looks like when it finally goes out, and then just put it in a pipe. And then, so these have been installed all over the country. They've been installed in the water and utilities industry, transportation and DOT, power utilities, and producing municipalities as well. Basically, you got a leak. The first thing you're going to want to do is do joint prep. So what you saw there was a little bit of calcium buildup that he was scraping away. And that's kind of a lot of drinking water applications. We find that there's like some mineral buildup, that kind of deal. The point of the joint prep is to get the interior surface of the pipe to be fairly clean and smooth, at least where the ribs of the rubber seal will be laying, so that those ribs can be in constant contact with the interior surface of the pipe all the way around. So step one would be joint prep, where we're cleaning out the mineral buildup and debris, that kind of deal. So in this instance, he's scraping away calcium. A lot of DOT applications, it's just mud and loose debris like that. And then any indentations. So like the texture of a concrete pipe is okay, that's all good. But if you can kind of fit your finger in it and it's a bit of a divot, you might want to cover that up and fill it in. And that might be a little bit of butyl rubber or a little bit of concrete patchwork, but basically you're trying to aim for a fairly smooth sealing surface. And previous repairs that extrude from the joint themselves might also compromise the seal installation, so we go ahead and clean that away. And as you can see here, this is what a joint would look like that's ready for installation. As I mentioned, the concrete does have a little bit of texture to it, and that's all fine and dandy, but otherwise it's pretty clean and pretty smooth, so it's ready. And then the next step is you're going to take the rubber, you're going to position it so that it's flush with the pipe. You don't want the pipe to be going this way and then the seal itself to be a little bit off kilter, because the rubber has a decent amount of give and you can kind of make it lay flat. But once you go into the later steps and start putting down those steel bands, you'll realize that it's not at all flush with the pipe. So you want to make sure that the rubber kind of runs flush with the pipe. Then the ribs, when they're making contact with the interior surface of the pipe, as that little diagram shows, you want 1 inch of clearance so that the ribs are 1 inch away from the joint or point of repair. And that's because during the installation process, you will probably have a little bit of shifting as to where the ribs are actually sitting, because later on we're going to apply pressure to those stainless steel bands, and that's going to cause the whole thing to kind of spread out and shift a little bit. You want that 1 inch of clearance, that way you don't have to worry about the ribs kind of shifting or migrating into the repair area. You want it to be in constant contact with the pipe all the way around where it's structurally sound. So once you have it positioned correctly so that the ribs are far enough away from the repair area, you might want to add a little bit of lube to those ribs so that it will allow for a little bit of shifting later on and to distribute the pressure more appropriately. Once you've done that, you're going to construct the steel bands. So these steel bands, they go out in pieces. Generally, they go out in 2 pieces, so there's not too many pieces for you to deal with when you're on site. So generally, you're looking at 2 pieces. You kind of just put the ends together and you loosely bolt them, which is what they're doing here. And the reason we start out loose is because those are actually expansion points, which we're going to allow the bands to expand upward, and the whole diameter of those stainless steel bands kind of get bigger and then press against the rubber. So loosely connected and then laid on top of the rubber and the designated channels. And then you're going to go ahead and expand the bands. So assuming we're looking at a 2-piece band, the first one that you're going to expand is just going to be a placeholder wedge. So you're going to expand it so that the gap on the other side of the expander and on the other side of the stainless steel bands, as it gets bigger, as the whole band expands, that gap will get bigger. You're going to put a placeholder wedge in there, usually about 1 inch. And then once you're done that, you're going to go to the other expansion point in that same band. So you have 2 expansion points on either side. The first one gets a placeholder wedge. The second one you're going to actually bring up to pressure. And when I mean up to pressure, that is determined by the diameter of the pipe, the material of the pipe, and that's going to be something you're told prior to getting onto the site, so you'll know what that is. But we're going to just say it's 3,000. You're going to get to up to 3,000 pressure on that expansion point, the final expansion point in that band. Once you get it to 3,000, you're going to go ahead and tap around the interior of the band to disperse that pressure. It's called seating the bands. So the first expansion point is a placeholder wedge, and the second one you bring it up to that 3,000, let's say, and then you're going to go ahead and tap that retaining band as he's doing here. And the other person will be watching the pressure. If it dips, you'll point out, hey, it dipped when you tapped here. You're going to tap around that spot until the pressure then stabilizes. Once the pressure is stabilized and you're able to tap around the entirety of that band and the pressure doesn't drop anymore, you know there's no more shifting and you're good to go. And then your next step is, of course, you're going to lock that wedge in place underneath the retaining band. So as you can see there, once you've got it up to pressure, once the pressure is stabilized, you lock in a wedge under the retaining band. Once that wedge is in place, it takes the pressure off the expander head and you can pull the hydraulic expander out of place. The final step, which you will not necessarily have to do in every application, is an air test. These are generally going to be used in potable applications, but sometimes the owner of the project will request that they're in there. So basically what this is the seals go out with a test valve, an air test valve built in. And if you have to air test your seals, the first thing you're going to do is you're going to open it up with a little Allen wrench. Then you're going to attach a tube to it and pump 5 pounds of pressure behind that rubber. Once the pressure has been established as 5 pounds, you're going to maintain pressure because you might lose a little bit here and there, and then you're going to spray around the outer edge with a soapy solution. So maintaining that 5 pounds of pressure, and then spraying with the soapy solution, and then inspecting for bubbles. Basically, you're looking for escaping air, anywhere that there might not be a perfect seal, kind of like checking a tire for a flat. So once you find a few bubbles, you're going to tap and try to redistribute pressure a little bit, especially in that location. And once the bubbles have all been taken care of, and you keep the pressure at 5 pounds and you keep spraying with water and you're not getting any more bubbles, you know you got a good seal. So you can go ahead and close up the Allen wrench lock there. And then it's just that easy. You've eliminated your leak and your pipe has been rehabbed. So the general requirements for our seals is that the pipe is man entry size. So that generally means 24 inches and larger in diameter, and the pipe has to be structurally sound. This is not going to save a pipe that's ready to collapse. And in circumstances that your pipe is too small for man entry, we do have other options, but that is a different topic for a different day. Okay, so we're talking about the customizability and flexibility of the seal. A couple of things to note. The general seal, the standard size, the standard width, has a coverage area of 5.75 inches. In circumstances where the pipe has greater separation or more of an offset, you might need to use our extra wide or double wide. The double wide having a clearance or a coverage area of 16 inches. And then the image on the right of the screen there is a seal with a whole bunch of retaining bands, and that's generally going to be in a lot of power applications or applications with a lot of high head pressure. DOT and stormwater culverts, they generally just need 2 bands, with the exception of the double wide, where we generally recommend 3 bands. But that massive, 7 bands, that's not something you guys are generally going to have to deal with. Just want to let you guys know that's another thing that can be done. Okay, so our most basic installations, the ones that we do most frequently, is circular pipe repair. So a lot of stormwater culverts is our bread and butter, really. And so that's what this would look like here. You go in, hopefully the joints aren't too bad, you put in the stuff. And then we do some large diameter, which the process is more or less the same, but you might need scaffolding to reach all the expansion points, because as the seals get bigger, we generally break those retaining bands into more and more pieces for easier shipping, easier movement, all of that kind of deal. So you might have more expansion points within one of those seals. The installation process stays almost the same. The first set of expansion points all get placeholders, and the last one is where you go ahead and you actually bring it up to pressure, whatever it is for your application. But the process is fairly similar, fairly straightforward. We do some small diameter stuff too. The smallest we can do, generally speaking, is 24 inches. That's when we can get people in there and actually install these pretty easily. Anything smaller than that, it might not work. There are circumstances if the repair area is towards the end of the pipe where we can kind of just reach in. We don't have to get our whole body in. That might be an instance where we can go a little bit smaller. Generally, it's 24 inches though. And this has to be shipped with additional materials, but we can do corrugated. Basically, we have to kind of fill in the indentations of the corrugation either with concrete or butyl rubber to achieve a proper sealing surface. So it takes a little extra time, a little extra materials, but you can do corrugated as well. And the same kind of applies for our irregular shape installations, which are the box culverts, the elliptical, the D shapes, and many others. These can be done, they take a little extra time and a little extra materials. So the extra materials generally being anchors and hold downs that run along the outside of the retaining bands, as you can see in the pictures on the left, and that D-shaped one that he's standing in, you can see along the bottom at the invert of the pipe there. Those are kind of the anchors and the hold downs, which apply additional pressure to the retaining bands. So that's something that's necessary for irregular shapes. Also with very sharp corners, as you can see there, you might need a transition over that corner, like a corner form, which we can manufacture for you as well. Again, possible, just takes a little extra time, a little extra material. And then end seals. So it's not always this or that situation with liners. We have installed these at the end of a liner before. So when I've gone on job sites, I have seen the occasion where the liner looks like it's fairly intact, but the end, the lip has kind of come up a little bit, and the integrity of the entire liner was then compromised because water backtracked, kind of lifting it throughout. So our solution to that is just an extra layer of protection at the end, which we have suggested on several projects where you would just go in and install this over the end. And these have also been some of the instances where we have done pipe that's smaller than 24 inches because you're looking at the end of the liner, sometimes the end of the pipe. As you can see on the left there, you can just kind of reach into the pipe and install it. So I think that one might have been 18 inches, so that's a good example of one of the smaller ones. But basically, it's just an extra layer to protect a previous repair like that. And mostly the power plant, so I won't go into this too much, but like expansion joints can also be replaced with HydraTite, and so that is what that would look like. These have been installed underwater as well, so these are some divers from contractors we know. We have people we can get you in contact with who can help you do that, and our seals do work sometimes underwater. And earlier we mentioned that there are 3 widths to the seal. So you have your standard, your extra, and your double, for the double being the most coverage you can get with a single seal. But imagining that the damaged portion is more extensive than the double wide can cover, we are able to interlock these in a sleeve-like situation. So you interlock them so that you have one seal facing down, one facing up, and then one facing down. And I'll show you what that looks like, kind of like that, okay? So they can cover more area. You can do that as long as you want. The longer you do it, the farther you go with it. It becomes less economic, and you might think about other repairs. But interlocking at 3 of them or 9 of them might make more sense economically, depending on your circumstance. So we've done that a few times. All right, so why HydraTite? So other repairs, dig and replace is, not necessarily most efficient with time. It's more disruptive to traffic. Lining is less of a targeted repair. It might make sense in certain applications, but a lot of the times it's the joint or a point that's causing an issue in your pipe, causing infiltration. So if you can go ahead and target that, you're going to save time and money. When it comes to grout, a lot of the time I see it falling out pretty fast, and I'm looking at 5 to 10 years with grout, whereas if everything is going right and the application is pretty normal and the installation's good, our seals are going to last you around 50 years. So you're looking at replacing the grout maybe every 5, and you just one and done. It's the next person's problem when you put in our seals. So that is kind of why us against other repairs. And then, so this technology has been around for a long time. It started up in Germany as far as I'm aware. And there are other people that do something similar. Our selling point is the ribs. So a lot of our competition have this convex design, and when it's pressed up against the rubber, it kind of does this. You got some contact with the interior surface of the pipe, but ours has more of a concave design, and when you press that up against it, it kind of spreads out, giving you more rubber to surface of the pipe connection, like you're getting more touching. It's going to create a better seal. And also on top of that, I think the other selling point for us versus others is we're a bit of a smaller company. We do a lot of custom work, so the irregular shapes, the larger companies might not be willing to do that. We have a better response time, all of that. And then final example here, this was Alabama's DOT, where I actually was the installer for that when we were getting on their QPL. And as you can see, there were some like mud daubers that had built their nest in there, had to pull those away, remove anything from the interior surface that would mess up the seal. And in some installations, such as this one, we were requested to kind of put in a fill into the joint itself, and that's a little bit of rubber there. Sometimes it's concrete. It just depends on what the owner of the project wants. And this application, they requested I put in some rubber filler, just as an additional layer there. Then I put the rubber in place. I worked out all the oddities, the bumps and the humps, smoothed it up against the pipe, put in the first retaining band, and then I locked that in place with one of the wedges. That's what that looks like halfway through. And then I went in and locked the second retaining band in place. And this whole installation took me about 45 minutes. And it's simple installations like this, if you get used to the installing process, you'll be able to do even faster. Our field crew can do it a lot faster than I can. I'm an office guy, but it also, that speaks to it. If I'm just the office guy and I can do it in 45, it's pretty simple technology. So yeah, that is pretty much, I have everything. Jennifer, do you have anything I left out?
No, you covered everything pretty well.
Awesome. Do you guys have any questions or anything I should go more deeply into?
So, generally speaking, is this a product you guys install? Or is it something you would install the first one and then, give us a tutorial on how to install it ourselves?
So it kind of just depends. So we can do trainings. We can have, our guys, our reps in your area would be VEWS, who I believe are in this meeting as well. So they would be the installers over there. So when it comes to the purchasing everything, we kind of run it through them. But the general packages we can do are like trainings or full installations or whatever you need.
Hey, Caleb, I can add to that. This is Don LeBlanc from VEWS.
Mm-hmm.
Good morning, everyone. So yeah, right to Caleb's point, we are your region representatives for HydraTite, and we are also trained on the installation. But if you guys need, 1 or 3 sources for bids or whatever, or if you guys want to get trained, that is something we can assist with as well. I will say the HydraTech crew, as Caleb mentioned, is obviously the most experienced. They're awesome. They're efficient. We will often quote their services as well as their products. So there's all kinds of ways we can, pardon the expression, skin the cat, but we can get it done for you, no matter how you want to do it.
I assume that goes for any prep work as well? That would be required?
Yeah.
Yes, sir. Indeed.
Another question I had was, I think you kind of covered it, but is there a maximum, gap between pipes that you would, or joint that you would span? I know you said you could overlap and put multiple bands in there, but wasn't sure if there was a gap or size you would prefer.
Yeah. So the general.
Do you want to touch on the band, the stainless steel band behind the backer band? Did you touch on that already?
I did not touch on that one, but let me kind of give a little brief overview of what he was saying. I can kind of go into that too. So when it comes to coverage, you're looking at 1 inch of clearance from the ribs, from the repair area. So like the standard, we would recommend the repair area or the separation just be like 1 inch or 2, a couple inches. That gives you that bit of clearance. This extra wide has 9 inches between the ribs. So if you have 1 inch of wiggle room on either side, you're looking at about 7 inches of coverage. I would not necessarily say extra wide would cover all the way up to 7 inches, because generally speaking, they're not perfectly flush. So they're also going to have generally a little bit of offset as well. So you kind of want to take that into account. But like the maximum it could cover is 7 inches. And then the double wide has 16 inches between the ribs, but you're going to want, that 1 inch of clearance and also a little bit of give for offset as well. And as for the backing bands, there are different situations where you would want to do that. And what that is prior to putting down the rubber, you kind of put this steel band, it's a little bit thinner than the retaining bands, against the interior surface of the pipe, and then the ribs are placed of the rubber on either side of the backing plate. And Jennifer, that would be used in what kind of circumstances?
Anything with any kind of infiltration. You don't want the EPDM rubber sleeve to balloon at all. So if you've got sediment or anything coming in, you're going to want to put that backing plate on, as well as the pressure in the pipe to where it's not forcing that rubber through that
We're in a meeting right now, Don.
separation.
Yeah, so high head pressure, or if you expect a lot of the debris to fall onto the pipe, it's just kind of an additional layer, or a lot of debris to fall on the rubber, it's an additional layer of protection behind. So a lot of the DOT stuff that we've done in Ohio hasn't needed that. I have been on a project where we did have to put those in before. So it depends, but head pressure and lots of debris.
Yeah, there's been instances, this is Don again, like I'm up in New England, so in a lot of stormwater culverts, like Caleb was mentioning earlier, inherently what happens is the fines tend to fall out, right? So you end up with rocks or whatever the contractor used back in the day to backfill that pipe with. The larger stones are left over. So your fines are usually washed out. And as Caleb mentioned, we want to try to span that so we have something to push up against, like especially on a double wide seal, if we want to get a third or a fourth stainless steel backer band to press up against something tangible, then we're going to want to use an additional backer band for that in many instances where the gap is large.
Okay. Yeah, I mean, I saw, the part of your presentation where they showed the rubber going in. I was going to ask if you had ever grouted the joint and then installed this, but it sounds like you guys have a couple of methods that go about securing the joint ahead of time if needed.
Yeah, there are many instances where, an owner might say, hey, can you parge that joint a bit up before you put your HydraTite seal over? And as a standard practice, it's not going to hurt anything, right? So we would often encourage putting some filler material in there just to help prevent any more of those fines from migrating even behind the HydraTite seal once it's in place. Packing the joint is never a bad thing.
All right. Just one more question that I had is, it seems like most of your examples were of concrete pipe. I think I saw some plastic in there, and maybe a picture of corrugated metal. We are dealing with a lot of failing metal pipe around here. I wasn't sure how frequently you use this product on metal pipes. Is that recommended?
Yes, so we've done it on metal pipe in general, corrugated metal pipe. Yes, it has been used. I would say the most frequent use is concrete. That's why there's a lot of pictures of it, but it's definitely something we've done before.
So yeah, I actually used to work for Contech Engineered Solutions, the piping folks that do the stormwater. And it's an interesting, funny thing about pipe. What all of them do in the industry, Contech, Lane, whoever makes corrugated metal pipe, you may already know this, so I apologize. But for example, they would, back in the day, sell a 12 gauge pipe. So you have a nice thick conveyance pipe, but the bands are 1 or 2 gauges thinner. So your bands are typically, as you're noticing, the first thing to go, right? So your corrosion or your abrasion has affected the bands, and the pipe may look actually not that bad on either ends of the joint, but the joints come undone completely. So because it's on the soil side, you got the pH, you got the corrosion, abrasion, those bands are usually toast, even if the pipe might be still okay. So you're absolutely right about that.
Okay, yeah, I mean, that is all the questions I have. I don't know if anybody else has any.
All right. Well, have a wonderful day, guys. I hope it was informative, and have a good one.